Welcome everyone, and thanks for showing up to my session. I actually presented here last year and the year before as well, so I'm happy to be back. Thanks for inviting me, wearing the Italian VMUG shirt. Thanks for that, guys. I'm hoping to be back again next year, so hopefully this session will go well. I'm going to talk about virtual SAN today. I did a short introduction last year, spoke about virtual SAN for about 45 minutes. Explain to you guys the basics, what it's about. I'm going to do something similar this year, but I'm going to tell you what's new for vSphere or for VSAN 6.1, which is part of vSphere 6.0 update 1, confusingly. I'm also going to talk about some of the futures and some of our other plans around vSAN. So hopefully you guys find it interesting. This is the agenda of today. As I said, I'm going to go over some of the details of vSAN itself. We'll do a short deep dive, which basically explains some of the aspects of virtual SAN, some of the terminology that's part of it. Then I'll show you some of the specifics around version 6.1, things like stretch clustering, which I think is probably what a lot of you guys will be interested in, or things like ROBO configurations. And then we'll look at some of the futures. Before we get started, I always throw this slide up there. And this is basically about the software-defined data center. I'm pretty sure that you guys seen this probably 1,000 times already, maybe even more. In my opinion, if you look at the software-defined data center today, I think there's a couple of challenges that we still have. The compute challenges have, mostly been solved. Everyone has vSphere up and running, vSphere 5.5, 6.0, or whatever it is. It runs smoothly. But there's still a couple of challenges in most of the data centers. Networking is one of them, and storage is another one of them. Are there any storage people in the room? Any storage administrators? A couple of guys. Okay, so hopefully you'll enjoy this session, and I won't be offending anyone in a typical Dutch way. But let's get started. Does any of you guys recognize these type of people, SAN huggers and server huggers? I'm guessing that a bunch of you guys actually were this guy in the past, and I used to be one. I used to be responsible for this large physical environment. We had over 400 servers, Windows NT, you name it, Novell, all of that stuff. I wanted to say crap, but let's call it stuff for now. We love the physical world, but it's too difficult to maintain. And the same, from a server perspective, also applied to the storage world. When it comes to storage, and you look at how you need to maintain your environment today, how you operate it, creating LUNs, creating disk groups, it's kind of challenging, figuring out, how many IOPS does my application need? Can my array actually serve the needs of my application? Then you start having discussions around replication. It becomes really, really challenging fast. And I think a lot of these people started realizing that that's the case. So the world is, it's changing, it's shifting. And luckily, there's a whole bunch of smart people within our organization, VMware, but also within EMC. And a lot of people realize that a change is coming ahead. So we need to start making changes to the world right now. But we can still have some good fit for the old material out there. We can use them as a fridge or whatever. I think Chad is going to be up here in a couple of sessions. So hopefully we can ask him some questions about that, how he sees the world changing, and how we can use the old EMC equipment for newer purposes. But we'll get to that later. The reality is, though, when you start talking about new storage solutions, that it all starts with hardware. Although, we're making jokes about it, saying hardware is going to disappear, it's all going to be part of the storage world, everything is going to be software-defined. Reality is that if your hardware isn't spot on, if you're not using the right hardware, then from a software perspective, you can't go anywhere either. Last week I was talking to a customer. They were planning on implementing vSAN, and they had equipment already sitting there. They said, well, can we reuse the equipment that's there? It was just decent HP equipment, nothing wrong with it. The servers were fine. The only challenge they had is that they had onboard disk controllers which had an extremely low queue depth. He said, well, maybe we can still use that. It's quite expensive to buy new disk controllers. I said, well, the way it works today, and that applies to any solutions out there, if you put crap inside the solution itself, what will come out is going to be crap as well. So, keep that in mind. It relates to vSAN, but not just to vSAN, also other types of storage solutions. Hardware is still really important. And the key reason you're seeing a lot of these changes in the industry today, some of the things like Vaughan spoke about in the previous session, it's all about the hardware changes. So the introduction of things like flash, 10 gig networks with extremely low latency, but also things like new SAS connections, for instance, so faster SAS connections on the motherboard, you name it. That enables us to start building smarter solutions. And vSAN is one of those. Now, if you ask VMware, what is your goal with this software-defined thingy? What is your goal with vSAN? I think most of these will be familiar to you guys, because it's kind of like the same story we had with vSphere. With vSphere, we would tell you, it's all about simplicity. ease of provisioning, you name it, same applies to vSAN, of course. And then there's the performance and scalability aspect. I will show you some of the performance numbers that vSAN, or performance details that vSAN can provide you. I don't think that's the most important thing. For your managers, it's probably typically cost. We need to drive the cost down, and we need to do that, we need to be capable of doing that by still having some form of choice. Now, when we start talking about vSAN, when it comes to choice, we're not talking about the hypervisor itself, because it's integrated within the VMware layer itself. We're talking about the choice of the different hardware vendors. So you can either pick HP, Dell, or whatever you prefer. But that's one of the, those are the key goals that we have from a vSAN perspective. Now, the reason we started doing vSAN is when we started with the hypervisor itself, after a while we realized that we have this platform and we have these virtual machines sitting on top of it, and all of this data is flowing through the platform itself. Can we start doing smarter things with that data itself? And of course we can. That vSAN is one of the results of that. But vSAN isn't just one of those things that my team works on. So I'm part of the storage and availability BU. One of the other things that we, for instance, work on is virtual volumes. Exact same thing applies to virtual volumes. The other thing that we are working on, I don't know if anyone has heard about it, is the vSphere APIs for I/O filtering. They are all about filtering IOs, doing things like caching or replication. That's also part of the same platform, which is also embedded within the hypervisor itself. So vSphere is the key reason we are capable of doing vSAN today and going forward, and making those changes in a rapid fashion as well. But it's not just vSAN. Whenever I do these types of sessions, this is one of the slides I have up there. And the funny thing is that if our marketing team does these sessions, you will never see this slide up there. Because storage policy-based management, it's a fairly long name. It doesn't sound too sexy. I don't know if anyone thinks it sounds sexy, but storage policy-based management doesn't sound exciting. But actually it is. So in today's world, when you provision a virtual machine and you don't have storage policy-based management, you talk to the storage administrator, try to figure out which data store has certain capabilities. Is deduplication enabled? Are we compressing the data? Do we need to replicate it? Am I looking for some form of stretch clustering? You name it. You need to be aware of all the capabilities of those data stores if you don't have storage policy-based management. What we are aiming on doing is, with the storage policy-based management framework, is allowing you to deploy virtual machines by simply attaching a policy to that virtual machine. And the policy will contain all of the details. So we'll create a simple policy, and the policy could be something like, I want to reserve a certain amount of capacity, which is up there, or I want to provide a certain level of availability. As soon as you specify those in the policy, you attach the policy to the virtual machine, all the smart things will happen on the back end. So all of the logic is built into the system itself. This applies to both vSAN, virtual volumes, the vSphere APIs for I/O filtering, but in the future, or actually in this release already, with Site Recovery Manager as well. So you can see that all of the storage and availability type of products are heading into this direction, and there's a reason for it, because it makes your life easier. You don't need to open up that spreadsheet anymore. You just deploy the virtual machine, attach the policy to the virtual machine, and you're done. If for whatever reason over time the application owner comes back and says, well, actually, it was placed on a LAN that wasn't replicated, but now it's going into production, it's becoming more important. I want to enable replication, then using the policy-based management framework, you attach a new policy to it, or you change the policy, and automatically things will start changing on the back end. That again applies to all of the different types of storage solutions that we offer today. So both vSAN and vVol will be capable of doing that. But what does that look like? Hopefully most of you guys are using the web client by now. If anyone still thinks it sucks, let me know after the session. It's not about the web client, but I'd like to have a discussion about that, because I think it greatly improved with vSphere 6.0, and there's more improvements coming up. But in the web client, it looks fairly straightforward. You have this policy, it's attached to a virtual machine, and if you look at your virtual machine, you will see this section that says your virtual machine is compliant to the policy or it's not compliant to the policy. Fairly straightforward. If it's compliant, the virtual machine is happy, you are happy, you don't need to make any changes to the environment. If for whatever reason it's not compliant, you need to figure out why it isn't compliant. In the majority of cases, especially when it comes to vSAN, that usually means that a failure has occurred. So a disk has died, a host has gone missing, something like that. So in that case, at some point in time, vSAN will start recreating the missing components, and then the problem will be solved. You can actually also go to the UI itself and just say, reconstruct data, and it's reconstructed typically within, depending on the amount of data you have, of course, but we're typically talking about 15 minutes, 30 minutes, depending how big the virtual machine is, and then you will see this going green again. But if there's one thing I want you guys to take away from the session today is that storage policy-based management is one of those key things that not a lot of people are using today, but is going to be really important going forward with all of the products that we'll be delivering. So what about that virtual SAN thingy? I've already mentioned it a couple of times, and I've just thrown all of the keywords or some of the buzzwords that people like to use for virtual SAN up on this slide. Hyperconverged, software-defined, distributed scale-out architecture. Those are some of the terminology that you will hear when you start talking about vSAN. But what is it? Which one of those three is it actually? Well, I can tell you that's actually all of those three. vSAN is a hyperconverged solution, in my opinion. It's also a software-defined solution, but above all, it's a distributed scale-out storage platform. And I think the platform word is key here, and we'll get back to that at the end of the session. On top of that, it's fully integrated with the vSphere platform. Is anyone already using vSAN today? Can I see some hands? Okay, a couple of people, cool. Those who aren't using vSAN today, after the session, just go out and start testing it, please, and give me some feedback. If there's any reason you're not using it, I would like to hear that as well. But the cool thing about vSAN, as I said, it's a scale-out solution. It starts with 3 nodes. You can go all the way up to 64 nodes. And if you don't want to add nodes, but you want to add disks or you want to add flash, you could do that as well. I think that's the great thing. It's not only doing scale out, but it could also do scale up, depending, of course, on the type of hardware you've selected. And that's where the choice comes in. If you're an HP shop or you prefer Dell or IBM or Lenovo or any of the other vendors, you can pick any you want. Now, the typical question that then comes up, okay, that sounds cool. It's a scale-out storage platform. It's probably easy to install. What are we talking about? What are customers using it for? How many customers do you have? This is the latest number that we've announced, which is about 4 months ago. So 2,000 customers in the first 15 months and still growing rapidly. So the number is probably a lot higher than that. I'm not going to state any numbers because I'm pretty sure that the lawyers at VMware will probably get me fired. But you can imagine that this is close to the other digit. Now, I put 2 pictures up here. They're not just random pictures of a cool submarine and an oil platform. These are actual customers that we have. So the oil platform is, I think, probably one of the coolest examples that I have. These guys actually deployed vSAN on different oil platforms, which are stationed in different locations, and they are managing them over a satellite link to a central vCenter server in their centralized data center. So the key reason they are doing that is because on those oil platforms, there's no one that actually has an understanding of infrastructure itself. Majority of people on the oil platform, they know how to get the oil up, but they don't understand how vSphere works or vSAN works, let alone how a storage platform works. This is far easier for anyone to manage than any of the other typical solutions you will see out there. So that's one of the key reasons they deployed vSAN. These guys actually deployed it using all flash, which was also interesting because they used all flash in this case because they have a lot of vibrations on those oil platforms. And you can imagine that when you have a vibrating platform, there's a lot of movement, the disks will start dying fast. Not only that, you will also see that the performance with the disk starts degrading when the vibration goes up. It's something that not a lot of people would expect in a storage environment, but you see the performance actually dropping when the vibrations go up. The second one, the submarine, it's a customer that I'm working with today. What they are actually planning on doing is stretching a vSAN cluster across the submarine itself. So a stretch cluster implemented on that submarine. Key reason for it being is if they are being attacked for whatever reason, the data center at the front of the ship is being hit, they can still run on the data center at the end of the ship. So they have a dual data center set up with a control center in the middle. I think it's a really unique environment, and when people start asking me about mission critical workloads, does VMware actually support that? Does that work on vSAN? This is the slide I put up there, because I think it's pretty clear that a submarine is mission critical. Now we talk about use cases. I just spoke about 2 customers. What are some of the typical use cases you see then? Well, basically anything. I don't think there's a single use case missing here, and that's because if you look at our customer base, our customers are doing basically everything, ranging from business critical applications, could be SQL, could be Oracle, SAP. We have customers doing billing systems on top of vSAN, but also things like VDI, management clusters, for instance. So if you have a big environment, you want to have a separate management solution, then vSAN is typically also something that they start deploying. A DMZ is also a great example, which is kind of similar to the management cluster solution. And the key reason for people starting to look at vSAN is because in those cases, for instance in the DMZ, if you have a large production environment running on the same storage system, there's a denial of service attack. You can imagine that if there's a denial of service attack to your 500 web servers, they're still running on the same storage system, that your storage administrators aren't going to be too happy. So if you've isolated the storage solution by using vSAN, at least you mitigated that risk. So those are some of the reasons people are starting looking into it. Now, when you look at vSAN, there's a couple of ways that you can actually go about deploying it. I've put the EvoRail solution up there in the SDDC suite. This is something that the SDDC suite was formerly EvoRec, which was announced at VMworld. EvoRail was announced the year before that, and it's basically a pre-configured, pre-installed, almost ready-to-go solution that basically allows you to run a mini data center within 15 minutes. That's the EvoRail part. The Evo SDDC suite contains components like VROPS, for instance, as well, things like NSX. They also come included. It will take a bit longer to install and configure, because as you can imagine, doing top-of-rack switches and things like that will take a bit longer, but it's all part of that bundle. Majority of our customers, however, will go with the virtual SAN ready node configurations. The virtual SAN ready node configurations are basically pre-configured and tested configurations that you can just buy from HP, Dell, or any of the other vendors that provide these, and get vSAN up and running literally within 30 minutes, 40 minutes, depending on how fast you can install ESXi and configure vSAN to yourself. It's fairly straightforward, and hopefully the majority of you guys will be capable of doing that. So those are the three ways that you can do that. Now, if you look at the two different models that we have a hybrid solution and we have an all-flash solution. And Vaughan was just talking about all-flash storage and how the world of storage is changing because the price point of flash is dropping. And that's something that I'm seeing within my customer base as well. So over the last 18 months, I had a lot of conversations around hybrid solutions. You know, it was, from an economics perspective, hybrid made a lot of sense. It did significant amount of IOPS, so we're talking about 40,000 IOPS, talking about 1-2 milliseconds of latency, typically enough for the majority of environments. With all flash, people get excited about the fact that you could do 90,000 IOPS, which sounds really great for a single host. So we're talking to close to 1 million IOPS with 10 hosts. But more important, we talk the sub-millisecond latency is typically where the user experience comes in. The thing here is, though, now that the prices are changing, people are starting to see that in some cases the all-flash configurations are cheaper than regular SAS-based hybrid configurations. Of course, there's a difference in terms of licensing, but you know, it's getting more attractive to start doing all-flash. Now, when you start deploying these types of environments, they typically look like this. So typically, we're talking about a 2U server with about 256 gigs of memory, a regular 10-core Intel CPUs, and usually 2 disk groups. So why do people pick 2 disk groups? Well, the key reason people pick 2 disk groups is because the disk group is considered to be a failure domain. If the SSD that is fronting that disk group fails, that disk group is at that point in time not available. So that's one of the key reasons people started creating multiple disk groups. On top of that, a lot of our customers, they pick SAS over NL-SAS or SATA. And there's a simple reason for that. SAS will typically perform a lot better. It's not just the number of IOPS that the drives can provide. It's also the queue depth of the SAS drives itself, but also the controller. So keep that in mind when you start looking at things like vSAN. And probably most importantly, the network part. It's just a small bullet point at the end, 10 gig networking, but that's one of those things that, although it's not a hard requirement, it's definitely highly recommended to have 10 gig networks. The latency experience is typically a lot better, but B, from a performance standpoint, you will get a lot more out of 10 gigs than you would get out of 4 times 1 gig, for instance. So a lot of that, may sound, to a certain extent complex. You have things like RAID controllers, disks, flash, you name it. But it's not too complex, actually. When you pick that vSAN ready node and you've installed ESXi and you want to enable vSAN, it's a simple click. Basically, you turn on vSAN, you click OK, and everything will happen automatically at the back end. We'll be starting to grab disks locally. We'll start create that vSAN cluster, and we'll expose it to all of the virtual machines, or at least to the user, to the admin, so that he can actually start deploying virtual machines on top of vSAN. Of course, you will need to create a policy. There's a policy there by default, but if you want to have a policy that allows you to tolerate more failures or stripe across multiple disks, you name it, you can specify that in a policy as well. Before you do that, actually, you need to create a network. And that's typically where some of the challenges come into play. Majority of my customers, when they start deploying VSAN, apparently for whatever reason, it's really difficult to communicate with the networking team. I guess they're difficult people to deal with in general, I don't know. But no networking admins here, right? Just storage guys, okay. But for whatever reason, it's difficult to communicate with those guys and explain them that they need to enable multicast on the network, on the layer 2 domain itself. So that's one of those requirements that you need to write down if you're planning on doing a VSAN proof of concept, because that's usually where people end up phoning our support team. Now let's look at virtual SAN a bit deeper. I've already explained this last year. I'm not going to explain this in depth, but I just want to go over it briefly so that everyone is kind of on the same page, because I'm pretty sure there's some new people here. When we start talking about VSAN and you talk about a distributed system, people typically add the word file in between distributed and system. Just to be clear, VSAN is not a distributed file system. It's an object-based solution. Every single disk will be formatted with its own file system. This also means that if something happens to the file system, there's a file system corruption, you can't take out the full cluster itself. You can only take out that single disk. Now the way it works is fairly straightforward. Every virtual machine, or actually every virtual disk, is considered to be an object. And in order to provide some level of availability, we need to have different copies of that object, and those copies are referred to as components. In the example here, you see a VMUG object. There's a RAID 1 configuration. So you see 2 copies of the data itself. So there's one copy on the left side, the green one, and then there's a yellow one on the right side, and then there's multiple levels as well, and that's what we call striping. So we can explain that in more detail in some more depth in a second. But how do you get there? Well, first of all, you define the policy, and the policy will basically dictate what your object tree will look like. So if you have one or multiple components, if it's striped across multiple hosts, striped across multiple disks. So define this policy. In this policy, you can define things like the number of failures to tolerate, things like if you need to have a certain amount of read cache reserved, you name it. You can all define it in a policy. More importantly, when you make these changes, on the right side of the screen, you will actually see what the result will be of those changes. So if you set the failures to tolerate, which means the number of copies you will have of your data, to 2, and you have a 100 gig disk, you will see what the result will be of that change in the back, so in terms of capacity, which is really useful because it will allow you to do planning and also will allow you, well, prevent you from doing stupid things in the end. As soon as you define that policy, you assign it to a virtual machine. This is basically what the screen looks like. Hopefully the majority of you guys have seen this screen before. And then you deploy it, and it becomes compliant over time. It's deploying those virtual machines, it's deploying the copies of the data, it gets stored somewhere on the VSAN cluster, which just happens more or less, well, it seems randomly. Of course it isn't randomly. We place it in a specific way depending on how much capacity is available in each of the nodes and what it looks like from a performance standpoint. But we'll distribute the data, and then the user should be happy. Now the way we distribute this is based on 2 aspects. The first one is number of failures to tolerate. By default, this is set to 1. Basically, it means that if one host fails, your data will still be available. So what if you want to have, you want to be able to tolerate 2 failures? Well, then you simply set this to 2. Straightforward, within the policy, you can specify failures to tolerate is 2 or even 3. Keep in mind, though, as soon as you start increasing the number, the capacity requirements will go up as well. So if it becomes FTT is 2, you will have 3 copies of your data, so that 200 gig disk now becomes 300 gig or 400 gig, depending on what you specify. The other thing I wanted to point out is that witness thingy that sits in the right, you will see that randomly deployed throughout your cluster as well. And this is basically for VSAN to determine if a network partition happens, who's the owner of the data itself. So we have logic built into the system for that as well. Every once in a while, a customer comes up and says, well, I'm doing a lot of sequential I/O. It's coming straight from disk, or it appears to be coming straight from disk. I want to get some more performance out of the system. Especially you see this during backup times, for instance, or where you do things like Hadoop, and you do a lot of data analysis. That's when you start doing striping. The majority of our customers won't do any striping, but in some cases it's actually needed to reach that extra level of performance, and that's what you can specify in the UI. You can specify anywhere between 1 and 12 stripes, which basically means it will go across 12 disks. It could be across hosts, it could be across disk groups, depending on whatever VSAN feels it can fit that data best, or whether it will, from a performance standpoint, would fit best. So we make the decision for you in a smart way. But at least in this case, we assure it's striped across multiple spindles. On top of that, when you want to start placing your data in a smart way, you can also start defining these fault domains. You can imagine that when you have multiple racks or you have multiple blade chassis, for instance, that you consider that one of those blade chassis or one of those racks is a fault domain because it has a specific UPS system attached to it, or for the blade chassis, you can imagine that a full blade chassis actually fails. I've seen it happening in the past. That's when you start defining these fault domains. And as soon as you have these fault domains defined within the UI itself, you have the policy attached to the virtual machine. Now when VSAN starts placing a data, it will actually take the location of the data into account based on the fault domains that you specified in the UI. So I think that's a pretty cool feature. So what did we introduce with 6.1? Let's take a look. First of all, the first release was in March 2014, and it was basically the version of VSAN that allows you to deploy virtual machines. Fairly straightforward. You could do striping, you could set the numbers of failures to tolerate, but there weren't any additional data services. A year later, we released 6.0, and I actually spoke about the 5.5 version here last year. I didn't get to speak about the 6.0 version, but we'll discuss some of those aspects as well. And in 6.0, we introduced all flash, which is, I think, one of the key things. On top of that, the 64-node cluster, some customers were asking for it. Funnily enough, we don't have any customers using it today. The typical customer size, we're talking about anywhere between 4 and 24 nodes. 32 nodes is the most I've seen so far, at least in Europe. Maybe in the US that's different, but I haven't seen anyone doing 64 nodes yet. We also did a lot of changes in terms of snapshots and cloning technology. So the snapshotting technology and the cloning technology is what we acquired from Versto. From a performance perspective, it behaves a lot better. It actually behaves as you would expect it to behave. I don't know if anyone notices anything here up on the screen. If you look at the dates, the first release was in March 2014, the second release in March 2015, and then the next release is in September 2015. And I think that's one of the big changes that we've introduced. So from now on, going forward, you will see new vSAN features coming every 6 months. So what did we introduce? First of all, well, the hardware aspect again. I'm not going to go into any depth because I think you can find all of the details about NVMe and UltraDIMM on the internet, so you can just Google it. But basically what these are different ways of utilizing flash. So UltraDIMM is basically a DIMM that has flash soldered on the DIMM itself. It's a cool solution. One of the challenges I've had with it, or at least some of the challenges I've seen with it, is that not every single vendor supports it yet. So there's some changes needed to the motherboard, for instance, to allow you to use the UltraDIMM solution. NVMe, however, if you have an NVMe bus, it will work fine. It's just a faster way of leveraging flash, in my opinion. We just had one of the first devices being put up on the HCL, so it's by Intel. So if you want to use those, you can look them up and buy them. They're still quite expensive, though. More importantly, in the 6.1 release, I think, is this feature, which is the stretch clustering functionality. Are there any people using vPlex or NetApp Metro clustering? Okay, a couple of guys. I did a session on stretch clustering for vSAN in particular at VMworld, and at the end of the session I asked the same question, and at the end of the session a bunch of those guys came up to me and they saw the demo, how we actually enable vSAN stretch clustering, which is literally 2 or 3 clicks, and how you deploy virtual machines, which is again the same as you're deploying it today, so just a couple of clicks, you attach a policy, you're done. And everyone was impressed with how simple it was, because if you're managing those environments today, and I'm pretty sure that the guys who are managing those environments today can acknowledge that it's not easy to manage those types of solutions. Now within vSAN, what we did is we allow you to stretch your environment across 5 milliseconds round-trip latency, which should, for the majority of cases, you should be capable of just going across the country. At least that works well in the Netherlands, because we're a tiny country. I'm not sure if that works across Italy, but I think you guys do okay. But what we allow you to do is set up this cluster which is stretched across multiple sites, and if anything happens to one of the two sites, all of the virtual machines will be automatically failed over instantly. So we're not using anything like Site Recovery Manager or one of those types of solutions. We're using HA to start restarting virtual machines, which basically means that when it comes to speed of restarting virtual machines, you can start virtual machines up with about 32 virtual machines at the same time per host. So if you have 10 hosts in a cluster, you have, let's say, 20 hosts spread across two sites, you can start up 320 virtual machines at the same time, instantly. 5 seconds later, it will probably restart the next batch of virtual machines, so it's extremely fast. The one thing, though, I do want to point out is from a licensing perspective, of course, this does require a different license. So there's this advanced license, and you get this functionality as part of the advanced license. There's a couple of other things you need to know. Last year when I was here, some people after the session asked me, what about that data locality thing? Some of the other vendors are talking about how important that is. Aren't you guys doing data locality for VSAN? And my answer was no, we're not doing data locality for VSAN. We're still not doing data locality for VSAN for a normal cluster. Key reason for it being is that the latency for a normal 10 gig network is in the order of microseconds. So there's no real benefit for us moving data around because we're not getting a lot of gain. So the cost benefit aspect isn't what we normally expect it to be. For a stretched cluster, this is different. I just said you potentially could go across 5 milliseconds in terms of latency. You can imagine if you have two sites, you're writing, of course, to both locations because you need to make sure that the data is available, that every single write takes 5 milliseconds. Now, the same would apply to a read if you're not doing any type of site locality. If you're not doing any type of data locality, that's what we actually started doing in this release. So if a virtual machine sits in site A, all of the reads will be coming from site A. As soon as a virtual machine starts moving to site B, then of course we need to start making some changes and that the cache needs to be available in site B as well. The other thing I want to point out is multicast routing. I've already said multicast is one of those things that a lot of networking people are challenged with. And so there's two aspects here. First of all, there's a witness. To the witness itself, you won't need multicast routing when it comes to stretched clustering. But between the data sites, you will need to have multicast traffic. That can be both on layer 2 or on layer 3. We will support either of the two types of technologies or architectures. That shouldn't be a problem. Now, I've already said we're not using something like Site Recovery Manager, but actually we can. So if you have the requirement to have a third site and do something like availability across geo-distance as well, so async replication, you can use something like vSphere replication, which is supported for an RPO of 5 minutes when both the source and the destination are VSAN. That's what it is today. What we're planning on doing is making those changes for other types of storage solutions as well. So if you want to have VSAN as a source and then a NetApp or an EMC or a Pure Storage as the destination, or maybe the other way around, you should be capable of doing that with the same RPO in the future. That's just not available today, but that's something that we are looking at. So we just seen the we just seen the stretched cluster configuration, and one of the questions that a lot of people asked is, what about ROBO? We can already do a ROBO type of deployment. I just explained to you guys about the oil rig, where you have a ROBO type of solution. It's a remote office or a branch office in a way, managing it locally, but they still had the need for 3 or 4 nodes. So what we did with this release is actually allow you to do something like that with 2 nodes. It's based on all of the technology that's part of the stretched clustering feature itself. So it uses the exact same mechanisms. It's just that the setup, it's different. In this case, we'll have a central witness for multiple, you will have multiple locations with multiple centralized witnesses. In this case, you have 3 locations and 3 witnesses. And the distance to that witness can be a bit longer as well. Key reason for it being is we expect less virtual machines to be deployed in a ROBO location than in a stretched cluster. So 500 milliseconds to that ROBO location is not a problem. We already have customers starting to look into this, by the way, because it's one of those things that having just 2 physical hosts instead of 3 or 4 is beneficial from a cost perspective. Now that I mentioned the witness, that witness is a virtual machine. So it's fairly easy to set up. It's actually a virtualized ESXi host. It looks like a regular ESXi host. It just runs within a virtual machine. So it's a nested virtual machine. The key reason we introduced this is that from a management perspective, now you can treat the vSAN cluster as one thing. You can update it using the same mechanisms. You don't need to introduce a new mechanism to update the virtual SAN witness appliance itself. From a storage perspective, it has some requirements. We expect about 30, 40 gigs to be available for the witness appliance, so we can start storing those witness files for the individual virtual machines on that appliance. Other than that, we're not talking about a lot of resources, typically 8 gigs of memory, 1 or 2 vCPUs, depending on the number of virtual machines you deploy, and we will actually ask you how many virtual machines you're planning on deploying during the provisioning of this appliance as well. So we will make the decisions for you. One of the other things that we announced was advanced monitoring and troubleshooting using VROPS. I don't know if anyone is using VROPS, but if you are, we actually have a VSAN management pack. I know there was a lot of confusion around this, but as of today, you can actually use the VSAN management pack with VROPS standard. So if you're a standard user, you can start using the VSAN pack, and it will provide you all of these details around how your VSAN cluster is performing, how it's behaving, what some of the trends are. I think there's a lot of useful information in there. If you don't have VROPS, however, we also have this health check plugin. There's a couple of people already using VSAN. Hopefully you guys are using the health check plugin. If you're not, start looking into it, because we'll provide you a lot of detail. Today, a lot of people go into the command line, start figuring out what some of the, how VSAN is behaving, and they can do some of these tests. But you can do the same thing using the health check plugin. And it will provide you all of the details that you need. So whether that's, if your stretch cluster is behaving well, if multicast is configured, or if it's something like doing a proactive test. So how is my VSAN cluster performing? You can show all of that data in the UI as it stands today. So I have about 5 minutes left, so we're going to look at some of the future aspects of VSAN. So there's a couple of things that are coming in the near future. I think these are one of the key features that most of our customers started asking for probably a year ago. So we've been working on them for a while, but not all of them are really easy to implement. First of all, RAID 5 and RAID 6 over the network. This is what some of the vendors refer to as erasure coding. It's the same thing. Basically what we are doing is we're slicing up the data in multiple chunks and storing a parity chunk as well somewhere in the cluster. Now the key reason for doing this is overhead. If you have an FTTS1 configured today, every 10 gig disk will need to have another copy, becomes 20 gig at the back end. So from a capacity perspective, it's not too efficient. When you start using things like RAID 5, RAID 6 over the network, that 10 gig disk, now the overhead is only 1.33, so the 10 gig disk becomes 13 gigs. When you start using RAID 6, that 10 gig disk becomes 15 gigs. So there's a huge benefit in using this from a capacity standpoint, efficiency standpoint. But that's not the only thing. The other thing that we're introducing pretty soon, and this is actually going to be part of the beta, which will be out in, I think, a couple of weeks, is deduplication and compression. So you can enable this on a cluster level. And basically what it will do, I think Vaughan already explained in his session, but deduplication basically looks at the fact if the blocks are unique or not. And if they are not unique blocks, we can collapse those and then store them in a unique way. Before we store them in a unique way, we'll also deduplicate them. So we're still running some of these tests around which type of algorithm to use, but what it will look like is that every 4K unique block after compression will be stored as a 2K or 1K block. That's what we are looking at right now. We're still tweaking with some of these numbers. So that's something that's coming out in the upcoming beta as well. If you already have a vSAN cluster, you're interested in testing the new functionality, just walk over at the end of the session. We can have a discussion. I can give you names to some of the PMs, because we do have a limited set of customers that we accept to this beta. In terms of monitoring, one of the questions that people asked is, what about performance monitoring? Because there's a lot of data in that vSAN observer thing, but it's really complicated to use. So what we started doing is we started porting all of those graphs into vSAN, or at least the ones that are useful for customers. And whether you want to know, if vSAN is performing on a cluster level, whether it's performing on a host level, or maybe on a disk group level, or even on a disk level, you can have all of that information in the UI with the next version. So this is something that we expect to release early next year. More importantly, in my opinion, if you look at vSAN itself, and I already said, use the word platform intentionally at the beginning of the session, is that this is actually what we're working towards. So vSAN isn't just that virtual machine storage platform. Already today, you can have vSAN as part of your OpenStack environment, but you can imagine that in the future, you can also run things like containers scheduled by something like Mesos on top of your vSAN cluster. when I was preparing this deck, I didn't have all of these sexy words in there, so that's one of the key reasons I added Docker to make Massimo happy. And so if anyone is following Massimo on Twitter, just mention I used the word Docker for him. I think that's the end of my session. I just got the 1 minute left. I don't think there's any time left for questions, but if anyone has any questions, please come up to me and we can discuss those. I will more than happy to answer any of them. I will be around all day long. I think we also have a Q&A session at the end of the day. Chad, Vaughn, and Kelvin and myself. So more than happy to take any VSAN questions at the end of that.